Alright, oh man, I had everything right. There we go. Alright, so we're going to go ahead and knock these out. This is not mutually exclusive events, and we're pretty much just going to run with the big formula. Probability of A or B is the probability of A plus the probability of B minus the probability of, and I'm just going to write down both. I get really tired of writing A or B, A and B. Alright, so that's what we're looking for, right? Probability of A is 13 over 20 plus probability of B, that's 9 over 20, minus probability of both, that's 117 over 400. Don't let ugly fractions scare you. We have to get common denominator. That's the ugliest one. That 20 times 20 is 400. 20 times 20. So I'm going to multiply all of these guys by 20 over 20. So I'm going to eventually have everybody over 400. 13 times 20, well, 13 times 2 is 26, times 10 is 260. 9 times 2 is 18, times 10, 180. Right, 180 over 400, that's just reduces to that, and then that guy is still 117. Probability of A or B. So now the probability of A or B, 260 plus 180 is 440, minus 117 is 323. And thank goodness for us, that doesn't reduce. That's all I have left to do. Alright, get into a rhythm. Alright, probability of A or B, we have, so let's start with our formula. Probability of A or B equals probability of A plus the probability of B minus the probability of A and B. Now, I don't know if you noticed this or not, this is really the same formula as yesterday. That right there is what yesterday's formula was. Now we have that. If they are mutually exclusive, that guy is just 0. So you don't end up subtracting anything. Alright, quick aside, we took care of it. Probability of A or B, they gave us that this time. Probability of A is 3 over 5. Oh, by the way, this is like the one section, one chapter where we're going to actually do like a little bit of algebra. Probability of B is 2 over 5, but we can handle it. And minus, that's what I'm looking for. Question mark. That is 5 over 5. It's okay, Kate. It's alright. I like hearing her every now and then. Alright, that's just 1. On the Miro board, I have it all worked out where I can show you where it happens, but 1 is 100 over 100. 79 plus what is 100? It's missing 21. Which, again, thank goodness, does not reduce. We did this with complements. Remember, bottom minus top gave us the new top? Alright, now number 3, we have to just determine if it's mutually exclusive or not. So, I'm just going to draw. We have green marbles and orange marbles. Alright. 4 orange marbles numbered 1 through 4. 1, 2, 3, 4. I like drawing pictures. If you draw a picture, usually tomorrow we're going to work on tables and Venn diagrams. Every single problem, if I can't do it automatically, I either draw a picture or I do the table and Venn diagram. Tomorrow we'll do tables. Right now, you can always draw pictures. We also have 5 green marbles, numbered 1 through 5. Now this becomes so much more easier. Is it mutually exclusive or not? We're going for green with a number less than 2. Found one that is both green and less than 2. Remember, mutually exclusive would mean that I don't have both. There's no overlap. That marble counts as both less than 2 and green. A box of chocolates contains 4 milk chocolates, 5 dark chocolates, sometimes 4 white chocolates. Pretty good. Alright, you randomly select the chocolate. It's milk chocolate or dark chocolate. Are any of these those? Or any of those these? No, no overlap. There's nobody that's both. That makes it mutually directions make some of these problems so much easier. Alright, now we're on number 5. Now we have to just actually find the probability. I can't talk. A cooler contains 13 sports drinks, 6 lemonade, 7 orange. By the way, notice that I changed all the word numbers to number numbers. It makes it easier to find. 1 lemon lime and 5 of the orange drinks are cold. The others are still warm. We only grab a bottle. It's lemon lime flavor or warm. So sometimes, no, we're going to do the pictures today. All right. So we have 13 drinks, right? We have 6 lemon lime. I'm going to go back to this green stuff, right? I can't really draw good drinks. That's supposed to be a cup. We'll call it a cup. I decided I couldn't draw a bottle. 1, 2, 3, 4. The drawing's gonna get worse as we go. 5, 6, 7 orange. One, 2, 3, 4, 5, 6, 7. We're gonna make blue cold, right? 1 of the lemon lime and 5 of the orange drinks are cold. So 1 lemon lime, he's cold, and 5 of the orange drinks. 1, 2, 3, 4, 5. You could also just do C's and W's and whatnot. All right. So we want lemon lime or warm. So probability of, I'm going to go lemon lime, just double L's, or warm, I'm going to make it a W. I'm going to run out of space. It's going to be the probability of lemon lime plus the probability of W minus the probability of lemon lime and W. So, real quick, how many of them are lemon lime? Well, 1, 2, 3, 4, 5, 6 out of the 13. So we have 6 over 13 plus warm 1, 2, 3, 4, 5, 6, 7 out of the 13 minus the warm lemon limes 1, 2, 3, 4, 5. 13 minus 5 is 8. There you go. There's that one. Basket contains 5 apples. Great. Apples and peaches. You really don't want to see me draw an apple. My apples are going to be red circles. 1, 2, 3, 4, 5. 4 peaches. These are going to be orange. 1, 2, 3, 4. And I'm going to fill them. Oh, no, because hold on. We're going to make them different a little bit. One of the apples and 2 of the peaches are rotten. I'm going to use brown and make those rotten. 1 apple, he's rotten. And 2 peaches. 1, 2, they're rotten. Alright. Now let's get to work. So the probability that they are rotten, make that an R, or a peach, make that a P, is going to be the probability it's rotten plus probability it's a peach minus probability it is a rotten peach. And a lot of times if you have to do both things, you'll skip the word and just kind of put them together. that's sometimes legitimate, sometimes not. So I don't have that yet. Probably it's rotten. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 fruit total, and 1, 2, 3 of them are rotten. So 3 out of 9. Plus, probably it's a peach. 1, 2, 3, 4 out of 9. Minus rotten peaches. There's 2 out of 9. Notice those 2 fruit are the ones we counted twice, right? So 3 plus 4 is 7, minus 2 is 5. Hopefully you notice the advantage of not reducing that fraction as I go. By not making that 1/3, I already had common denominators the whole way through. So 5 over 9, probability it's rotten or a peach is 5 out of 9. Alright, that's it. Tomorrow is going to be making the word problems so much easier. But it can be tricky once to learn the pattern. Once you learn the pattern, this stuff's going to be a breeze and really useful.